Hi, welcome to our next level 3 trigonometry video. In this video, we're going to chat about the amplitude. Now, so far we've looked at 3 trigonometric graphs, the sine, the cosine, and the tangent. Right, straight into example 1. Let's go back and review what y equal to sine x looks like. Now, we're using radians. It's a far more common measure of angle in turn now that we're moving into level 3 and beyond. So here's what the sine graph looks like. Remember, it starts at 0, 0 and has a period of 2 pi radians, and it has an amplitude of 1. In other words, it doesn't go higher than 1 or lower than -1. Now notice we use this word amplitude for the height of the wave, but there are some people who think the total height of the wave is 2 squares. Even though they're correct, it is, the total height is 2, the amplitude is defined as, I guess, half of the total height. So this graph has an amplitude of 1. And when we write y equal to sine x, remember just like when we write y equal to x, we mean y equal to 1x. So sine x means 1 times sine x. There's a 1 out the front that's missing. We just don't write it. So this number out the front is the value of the amplitude. This graph has an amplitude of 1. So let's move on to this example, number 2, y equal to 2 sine x. Well, this graph has an amplitude of 2. It doesn't go further than 2 or below -2, so the amplitude of this graph is 2. So when we see a number out the front of a graph, like sine x, cosine, or tan x, it represents the amplitude. Right, what about y equal to 3 sine x? Well, it's just a sine x graph that has an amplitude of 3. Right, before we do some more examples, I just want to stop and look at this for a second. Let's draw the graph of y equal to sine x, y equal to 2 sine x, y equal to 3 sine x. Notice they are all the sine x functions. They all start at 0, 0. They all have the same period. They have a period of 2 pi. But they have different amplitudes, different heights. What about that last graph, y equal to 2.6 sine x? Well, that's just going to have an amplitude of 2.6 in between 2 and 3. Right, something else to note, that if I was to draw y equal to 2 sine x, this is the graph here, it's got an amplitude of 2, and I was also going to draw the graph of y equal to -2 sine x. Well, notice when I draw them side by side, they have the same amplitude, same height. So what has the negative done? It's not changed the amplitude because the amplitude's still 2. What it's done is it's flipped the graph upside down. Can you see that the purple graph is a reflection of the green graph? So the negative has made the graph a mirror image or reflection. So please be mindful when you see a negative, it reflects the graph. So the amplitude of -2 sine x is still 2. Right, let's get back to our examples. Example number 4. Here's the graph y equal to 2.5 cosine x. Well, let's just quickly draw y equal to 1 cos x, or y equal to cos x first. And this is what the graph looks like. Remember, the cosine graph starts at its maximum point and drops down and increases back to its maximum after a period of 2 pi. So here's what the graph of y equal to 2.5 cosine x would look like. It's the same graph, cosine, it's just got a greater amplitude. So let's remove the cos x and think about this having an amplitude of 2.5. Right, our last example, y equal to 2 tan x. Well, here's what the normal y equal to tan x graph looks like. Remember these asymptotes, these breaks in the graph, and here's what 2 times tan x would look like. It just makes the graph steeper. Right, so let's wrap up. We've talked about a number out the front of the sine, the cosine, or the tan is equal to the amplitude, the height of the wave. We're now going to talk in the next couple of videos about what B, C, and D are. Thanks for watching.